Hi students, welcome to lesson number 15 on experimental research design. And here we are also going to understand what are its advantages as well as disadvantages. Now the brief introduction. Research design brings together influences from the whole gamut of social, psychological and more technical sciences to create a tradition of empirical study stretching back over 50 years. A growing part of this empirical tradition is experimental, which has gained in importance as the field has matured. The purpose of experimentation is to study the effect of manipulated independent variable on the dependent variable. In educational setting, independent variable can be manipulated in different ways. An outline has to be drawn about the way a researcher would like to manipulate independent variable. The main objective of outlining the experimentation is to find out the true effect of manipulated variable. Certain factors creep in while manipulating certain functions. These factors either come from the process of experimentation or from outside. Their presence interferes with the treatment. Under such circumstances, true effect of the treatment cannot be achieved. In order to get true effect, the researcher has to apply certain checks or controls so as to parcel out the effect of intervening variables. Process of applying these controls is basic to experimental design or layout of the experimentation. These may serve as the criteria for classification of experimental design. And the objectives of this lesson is that the students will be able to define experimental design. They will be able to find out the different types of experimental design. Now, what is experimental design? Design for experimental studies was first used by Professor 𝗳𝗶𝗁𝗺 when he was working at 𝗳𝗏 Experimental Section, which is a center for agriculture research in England. He used to design this in doing agriculture research by dividing agriculture fields into blocks and by conducting experiments in each block. Experimental studies are concerned with testing of causal hypothesis. A causal hypothesis refers to causal relationship between two variables where one variable x determines another variable y. For example, if the researcher wants to test a causal hypothesis that students have good employment opportunities x who have studied in private schools y. By comparing the students who have studied in public schools and private school, the researcher can measure the two groups with respect to their employment opportunities. Experimental studies will reduce bias and increase reliability and will permit in drawing inferences about causality. A cause may be an act by impelling or by releasing. For example, you must be aware of billiards games. In this, the players will strike the ball which is impelled to strike another ball, which may in turn strike number of balls. In this case, the first impulsion is the cause of movements of the second ball and the subsequent balls. The second and subsequent balls are the effect of the cause induced by the impulsion. These studies are used to measure the cause and effect of the variables in particular phenomena. And the three conditions which have to be fulfilled to draw a causal inferences are: first one, the cause precedes the effect in time; second, there is an empirical correlation between them; and the third, the relationship is not found to be the result of the effects of some third variable and each of the two initially observed variables. Now, what are the characteristics of experimental research? There are three essential ingredients in the conduct of an experiment. They are control, manipulation and observation. Now, what is control? Control is the first essential ingredient of experimental method. Without control, it is impossible to evaluate ambiguously the effects of an independent variable. Basically, the experimental method rests upon two assumptions regarding variables. These are: if two situations are equal in every respect except for a variable that is added to or deleted from one of the situations, any differences appearing between the two situations can be attributed to that variable. This statement is called the law of the single variable. Second, if two situations are not equal and it can be demonstrated that none of the variable is significant in producing the phenomena under investigation, or if significant variables are made equal, then any difference occurring between the two situations after the introduction of a new variable to one of them can be attributed to the new variable, and this statement is called the law of the only significant variable. And the main purpose of control in an experiment is to arrange a situation in which the effect of variables can be measured. The conditions to be fulfilled under the first law can be obtained more easily in physical sciences. A high degree of control is much easier to achieve in a laboratory setting than in situation outside the laboratory. In the laboratory, there is only limited number of variables which can be manipulated easily. However, as social research is concerned with human beings, there are always many variables present in situation. To attempt to reduce social problems to the operation of a single variable is not only unrealistic, but perhaps impossible as well. Fortunately, we do not require such rigorous controls to be introduced in social settings, for many factors involved in such a setting may be quite insignificant and irrelevant for our study. To this extent, in social research, the law of the single significant variable is more appropriate. For example, if we were to study the effect of two methods of teaching alphabets to groups of adult learners, we are likely to select the two groups which are identical in every respect except in the way they are taught alphabets. But it is impossible to have two groups that are identical in every respect. So, the endeavor of the researcher should be towards obtaining two groups that are as similar as possible, at least in those factors that are thought to have an effect on learning alphabets. These could be general intelligence, motivation, reading ability, etc. Other variables that are not likely to affect achievements in learning alphabets can be ignored. Thus, in experimental research, in social research, we need procedures that permit us to use to compare groups in the basis of significant variables. Control is used to indicate an experimental's procedure for eliminating the differential effects of all variables extraneous to the purpose of the study. An extraneous variable is variable that is not related to the purpose of the study, but may affect the dependent variable. The experimenter exercises controls for instances when the groups are made comparable or extraneous variables that are related to the dependent variable. If a variable is known to be unrelated to the dependent variable, it cannot influence the dependent variable, and we do not need to control it for its effects. And the second one is manipulation. Manipulation of a variable is another distinguishing characteristics of experimental research. It refers to a deliberate operation performed by the researcher. In contrast to descriptive research, in which the researcher simply observes conditions as they occur naturally, the researcher in the experimental research actually sets the stage for the occurrence of the factors whose performance is to be studied under conditions where all other factors are controlled or eliminated. In social research and other behavioral sciences, the manipulation of a variable takes a characteristic form in which the experimenter imposes a predetermined set of varied conditions on the subjects. This set of varied conditions is referred to as the independent variable, the experimentable variable or the treatment variable. Then different conditions are designed to represent two or more values of the independent variable. These may be differences in degree or differences in kind. That is, the independent variable may assure two or more values and the difference in the values may be of quantitative or qualitative nature. Methods of teaching attitudes, socio-economic status, personality characteristics, types of motivation, etc. are some common examples of the independent variable in social research. For example, if the researcher compares two methods of teaching, then method of teaching is the independent variable and can be manipulated by the teacher. We may manipulate a single variable or a number of variables simultaneously. And the third one is observation. In experimentation, we are interested in the effect of the manipulation of the independent variable on a dependent variable. Observations are made with respect to some characteristics of the behavior of the subjects employed in the research. These observations, which are quantitative in nature, may constitute the dependent variable. This needs some explanation. The dependent variable in social research is often change of some type, such as attitude towards learning. We are often interested in explaining or predicting attitude. Since attitude cannot be measured directly, we can only estimate it through measures like scores in a scale. Therefore, strictly speaking, the dependent variable is scores or observations rather than change in attitudes. Now, we try to find out what are the designs of experimental study. A research design is very important for the researcher. A well-developed design provides a structure and strategy to control the investigation and extract dependable answers to the questions raised by the problem or hypothesis. It is the nature of the problem that determines the appropriateness of the design. We now discuss the experimental design and we will look at the relevant terms and symbols which we shall make use of. And first one, it is the x, which represents the independent variable which is manipulated by the researcher. It is also referred to as the experimental variable or the treatment variable. Y represents the measure of the dependent variable. Y1 represents the dependent variable before the manipulation of the independent variable x. It is usually a pre-test of some type administered before the experimental treatment. Y2 represents the dependent variable after the manipulation of the independent variable x. It is usually a post-test administered to subjects after the experimental treatment. S represents the subject or respondent used in the experiment. E group refers to the experimental group, the group that is given the independent variable treatment. C group refers to the control group, the group that does not receive the experimental treatment. R indicates random assignment of subjects to the experimental groups and the random assignment of treatments to the groups. Now, we will understand what are the different types of experimental research design. In different experimental studies, the effect on dependent variable is measured at various stages of experiment. Experimental design have been categorized based on the extent of control. Informal experimental designs normally use a less sophisticated form of analysis based on differences in magnitudes, whereas formal experimental design offer relatively more control and use precise statistical procedures for analysis. 𝗂𝗽 has discussed the following experimental designs, and the first one is informal experimental design, and it consists of various aspects. And the first one in that is before and after without control design. Second one, after only with control design. Before and after with control design. The first one, formal experimental design, consists of completely randomized design, randomized block design, Latin square design, factorial design, quasi design, and time series design. Now, let us discuss about the informal experimental design, and the first one under it is before and after without control design. In this design, a single test group or area is selected and the dependent variable is measured before the introduction of the cause variables. For example, a patient came to the hospital for treatment. The doctor will test or measure the patient dependent variable before the introduction of the treatment. The treatment is then introduced and the dependent variable is measured again after the treatment has been introduced. The effect of treatment of the patient will be calculated by the following formula, that is level of phenomena before treatment, that is x, that is treatment introduced, again level of phenomena after treatment y, and the treatment effect is equal to y minus x. The main difficulty of this design is that with the passage of time in approaching the doctor, variations will be found on the effect of treatment. Now, second one, after only with control design. In this design, two groups or areas, test area and control area, are selected and the treatment is introduced into the test area only. For example, the researcher wants to study the symptom of the disease. In this design, he can take patients and divide them into two groups. One group of patients who are approaching the doctor for treatment and other group not approaching the doctor for treatment. The dependent variable is measured in both the areas at the same time. Here the treatment impact is assessed by the following test area treatment formula, that is test area y, treatment provided, level of phenomena after treatment with control area z gives rise to level of phenomena after treatment z. Treatment effect is equal to y minus z. The basic assumption is such design that the two areas must be identical or similar with respect to their behavior towards the phenomena considered. This design is superior to before and after without control design. And the third one is before and after with control design. In this design, two areas are selected and the dependent variable is measured in both the areas for an identical time period before the treatment. Then the treatment is introduced into the test area only and the dependent variable is measured in both for an identical time period after the introduction of the treatment. For example, two groups of patient areas, one before treatment and other group without treatment will be measured. After the introduction of treatment to the test area only, the dependent variables will be studied again on both the groups. The treatment effect can be calculated as, so there are time period 1 and time period 2. So, test area, level of phenomena before treatment x, time period 2, level of phenomena after treatment y. So, control area in treatment 1, level of phenomena without treatment A, level of phenomena without treatment B, and the treatment effect is y minus x minus b minus a. This design is superior to the above mentioned two designs. This design may not be useful when the historical data, time and comparable control area is not available. Now, we will discuss formal experimental design, and under that first one, completely randomized design. This design involves two principles, that is principle of replication and the principle of randomization of experimental design. The main characteristic of this design is that subjects are randomly assigned to experimental treatments. For example, there are 10 subjects in post-graduation course. The researcher would like to study 5 subjects in group A and 5 under group B. The randomization process gives every possible group of 5 subjects selected from a set of 10. Even unequal replications can also work in this design. This design is employed when the experimental areas are homogeneous groups. Second one, randomized block design. This design is an improved over the earlier design. In this design, the principle of local control can be applied along with the other 2 principles of experimental design. In this design, the subjects are divided into groups known as blocks, and subjects in each block must be relatively homogeneous in respect with some selected variables. The variables selected in the groups will be helpful in measuring the relation between the dependent variables. The subjects in each given block must be equal to the number of treatments, and one subject in each block would be randomly assigned for treatment. The main feature of this design is that in these each treatment appears the same number of times in each block, that is two-way analysis is used for analysis of this design. Another important type is Latin square design. This design is frequently used in agricultural research. For example, the agriculture scientists want to experiment the effects of 5 different varieties of fertilizers on the yield of a certain crop, which is to be judged. In that case, the difference in the fertility of the soil and the type of seeds must be taken into consideration. Otherwise, the results may not be dependable. The results not only depend on the usage of fertilizers, but also depend upon the quality of seeds and the fertility of soil. To overcome such difficulties, this design is used. The merit of this design is that it enables differences in fertility gradients in the field to be eliminated in comparison to the effects of different varieties of fertilizers on the yield of the crop. Another method is the factorial design. A factorial design is one where 2 or more variables are manipulated simultaneously in order to study the independent effect of each variable on the dependent variable as well as the effects due to interaction among the several variables. Factorial designs are also of 2 types. They are simple factorial design and the complex factorial design. In the first type, one of the independent variables may be experimentally manipulated. The researcher is primarily interested in the effect of a single independent variable, but he or she must take other variables into consideration which may influence the dependent variables. In the second type of design, all the independent variables may be experimentally manipulated. Factorial design have been developed at varying levels of complexities. The simplest factorial design is 2 by 2 design. The 2 independent variables have 2 values. Now, the quasi-experimental design. One of the quasi-experimental design is non-randomized control group pre-test, post-test design. You would notice that randomized control group pre-test, post-test design is a true experimental design which we have presented before. The only difference on the quasi-expert design is that the groups are not randomized. Hence, they are unlikely to be comparable. In fact, it is on this ground that the design becomes quasi-experimental and not true experimental. Since the rest of the design related characteristics remains common with a randomized control group, pre-test, post-test design of the true experimental design category. We do not need to provide any further details on this design. The other one is the time series design. They generate on time data on the dependent variable before and after the experimental treatment. There are instances where it becomes necessary to compare changes in the trend of a particular phenomena or process or product. For example, Let us assume that learners' behavior to attitudes, achievements, etc. changes over a period of time. If a specific treatment is introduced in an institution to study the change in attitude or achievement, it is useful to study the trend through measurement at certain intervals before the introduction of the treatment. Instead of one-time pretest, the test is repeated 3 or 4 times before the treatment is administered. This generates data on the trend of behavior. Similarly, after the treatment is administered, instead of one time post-test, the post-test is administered several times at intervals. This provides data to derive the trend in the change in behavior. Since both pre-test and post-test are used over a time series design, the effect of the treatment on the dependent variable is tested by comparing the trends. The lesson begins with a discussion on the concept of experimental research, which primarily aims to establish causal relationship among different events in education situation under the controlled conditions. While conducting experimental research, different kinds of variables play significant roles in influencing the cause-effect relationship, which are also discussed. In order to carry out experimental research, the researcher has to adopt an experimental design, which is an outline or blueprint from the statement of hypothesis to the analysis of data for the experiment to be conducted. Experimental design has to be validated against internal and external criteria factors. In order to ensure internal and external validity to the experimental design, a check or control has to be put on the sources of error affecting dependent variables, discuss different purposes and methods of controls. Thank you.